As I was introduced, my name is Migas. I work as a front-end developer and designer. This title of Google Developer Expert is in web technologies. It doesn't mean I work for Google. And you can find me on Twitter under my handle, Shunshalicious. And the title of my talk is Fast but Not Furious, Debugging User Interaction Performance Issues. So for the past few years, I've had a chance to develop and maintain free open source libraries. They were all connected to animations, and they're pretty simple CSS libraries. And during the time of creation, I really tried to make them as performant and as accessible as it was possible. And I did a lot of reading on performance, like way too much for my needs. And I saw that there is one term emerging, like one term that was visible throughout all the articles that I could find. And this was perceived performance. So for those of you who don't know, the perceived performance usually is introduced as two things, as two metrics. First of them is first meaningful paint, which is a metric that tells us how long will it take to show any content to the user on the screen that is meaningful to them. So basically any text usually. And time to interactive, which is a metric that tells us how long will it take for the user to be able to interact with the contents of our page. And if you started searching further for perceived performance on the web, you would stumble upon a lot of articles on things like how to optimize critical rendering path, which basically tells us how to take a part of the code that is responsible for what's visible on the page above the fold, so like the top part of the page, and how to ship it to the user as fast as possible, so basically extract the code and ship it first. Or maybe about articles about how to use progress bars instead of spinners because they're going to make user feel that something is loading faster. They give the illusion of faster loading. Or maybe articles about how we should have a placeholder content on our page. This is what Facebook does. Like, we have these gray areas that mark the places where the content is going to be shown any second now, and the user anticipates that something will eventually show, so it feels that that the content actually is loading faster as well. Or even some services that would start uploading the user's content before the user even knows they want to upload. They only have chosen something in their media library, and they don't even know if they want to ship it to the world or not, but the upload might have started already. So I've read through all of these techniques, and I started wondering, is it really what we should be calling perceived performance? Is it really what perceived performance is about? Like, it's kind of felt a bit limited in some ways. So I'll tell you a short story to tell you what I feel, why I feel this way. So 2 years ago, I've had a chance to fulfill one of my biggest dreams and reach the sacred valley of Machu Picchu after a few days of trekking. Unfortunately, after the first day, I felt terribly ill of altitude sickness. You don't want to ask about it. But it was so bad that it was visible that I'm not going to be able to carry on. And I was given an alternative to go back to the city and after a few days just go by train to Machu Picchu. Of course, it's lame. Or I could mount a horse and just go up the mountain on a horse, which I'm not a very good horse rider, to be honest. So of course, I decided to go on a horse. It turned out that it was surprisingly pleasant, and well, a lot of people who decided to, like, they didn't decide it, they just didn't get sick. They had to go up the mountain. It was terrible for them, and I was there like 40 minutes earlier than anyone, and my way up was very smooth. But it turned out that there was nothing up the mountain, right? Like, you couldn't see anything. There was snow. There were clouds. Like, imagine going with the cable car to the top of the Table Mountain when there's clouds. Like, you don't see anything anyway. So while my way up was very nice and pleasant and way better than for other people, what I experienced at the top wasn't very pleasant. And this is something that I'm going to remember. And this is what we are actually doing with our websites, right? Like, we only care about We only care about how fast user will load the page, like how fast the content will be delivered for the user, but we don't really care what will happen next sometimes. I mean, I care. So what we now call perceived performance, like all these techniques, I feel that it should rather be called perceived load performance, because it's only about loading things. And while I feel it's still fine, like, to optimize these things, it would probably better to not have like only great loading performance and then leave users to themselves. It would be fantastic if we had a great perceived performance all the time, like not only during the loading, but also when the user is finally interacting with our page. So perceived performance shouldn't be only about first meaningful paint, time to interactive, but it also should be about having our interactions smooth at all times. And this is something that I'm really passionate about, so we're going to talk about it today. So the list of things that we're going to talk about. We'll talk about why sometimes interactions feel slow, about browser rendering and frames, about types of trigger changes in the UI, about how to test for interaction performance, and finally about some potentially dangerous UI patterns that you might already have in your web app, and you don't even know that they might be causing trouble for your users. So why sometimes interactions feel slow? The reason here is junk. So junk can be described as a stuttering, something that is just not smooth, something that feels just awkward when it comes to interactions or animations. Basically, this is junk. So once you see it, you are not able to unsee it. I'm sorry. And junk happens when the browser refresh rate doesn't hit the refresh rate of our device. So basically, what is happening, our devices, they just refresh their screen very often. And if the browser is not able to keep up with the pace, then we'll get this junk, this stuttering. So most consumer market devices have a refresh rate of around 60 frames per second. And this means that we have 1,000 milliseconds, that's 1 second. If we divide it by 60, it gives us around 16 milliseconds per each frame. But there are some devices hitting the market that have twice as many frames per second, namely the new iPad Pro and Razer gaming smartphones. So it means that we have to be twice as fast. We have only 8 milliseconds for each frame. So this is not a lot of time, if you can imagine. And while this is a standard in, for example, gaming industry, to have a higher refresh rate than 60 frames per second, it's not a standard in our industry yet. So game developers, they actually know that they have to have their interactions, like they have to have their games smooth, so they know how to work in between the frames, how to optimize so that the device they're running their games on should like render something really smoothly. And this is something that we don't yet think about. And I'm not saying that it's something that's going to be very common, like Retina screens. We had a revolution of Retina screens where everyone started to support higher pixel density screens. This might not happen, but if it happens, or if you really want to support these screens already, then you might need to be faster than we used to have. And to be fair, most of the animations or interactions on the web, they don't hit the 60 frames per second even. So how can we be like game developers? What can we do to help the browser to make it on time, to finish the frame, to avoid the junk and stuttering? First, we can offload the main thread. So maybe some of you know, but most of the things that happen in the browser, they happen in sequence, like one after another, and they don't happen at the same time. So if we have like big JavaScript task that will run for a long time, it can block, for example, our UI from rendering. So all these things happen one after another in one thread. But there's something called background thread, which was supposed to be for carrying a bit heavier tasks. So you can think of it as a bus lane, or for example, a VIP entrance to the party. Like it's supposed to be for really important things. Example can be if you go to the page that is not fully loaded yet, and if you see that some things are not loaded yet, but you can scroll freely, it's because scrolling is a background task. It was so important that the browsers moved it to the background thread. Unfortunately, we cannot manipulate the DOM from the background thread because of the security reasons, but we can do some other things. So we can, for example, use web workers for this heavy task. So web workers let us communicate with this background thread. And for example, if we have some heavy calculations, we might just take them from our app and put from main thread and put it to background thread, which will stop the main thread from being blocked. And probably some of the UI will be shown earlier. But we're not going to talk about the web workers today. We're going to talk about, like, once we take this heavy task and have our main thread, what can we do to optimize the main thread, to optimize what's left there? So the bottom line is, if we interact with the page, the browser needs to start serving frames, be it 60 or 120 frames per second, just as we were talking about a moment ago. And what exactly the frame consists of? So like a typical frame could have a JavaScript, recalculation of styles, layout, paint, and compositing steps. So you need to understand that these steps, they happen one after another. They don't happen at the same time. And the sequence is final. So you can't, for example, have paint before recalculation of styles, or you can have compositing of the layers before the JavaScript. If it turns out that some of the tasks need to happen at this moment, even though it was scheduled in the frame earlier, we might have to go through all the steps in the frame again. So redo the whole frame, which will probably cause the frame to be missed, and we'll have some stuttering, we'll have some junk. So what does the browser actually do during these steps? We'll go through it really quickly because this is something that we'll be able then to leverage and to maybe optimize our interactions in the end. So first, the change happens and an event is fired. It doesn't have to be JavaScript. It can be, for example, scrolling, hovering over elements, or just interacting with something that will change the looks of our page. Then the styles needs to get recalculated accordingly to what just happened on the page so that we would represent this change. After that, we might go through the layout step. So at this point, the browser will try to figure out which element is going to go where, how much space it's going to take, how big is it. So basically, just figure out the whole geometry of the page. And the browser is going to represent it as a collection of vector boxes. Of course, it's not going to be shown to a user in any way, but it's like conceptual. After we have our layout ready, everything is going to be rasterized and is going to be painted to the layers. So we basically take our boxes from before and we just put them to the layers. We paint them to pixels. So layers. You can think of layers as layers in Photoshop. So if you have one thing on one layer, another thing on another layer, they can be moved around freely. They don't affect each other. It's very convenient when it comes to interactions and animations. But if you have two things on the same layer, they're kind of glued together and they need to be separated before animations, for example. By default, the browser will create only one layer with everything on it, but there are some special things that will make the browser create another layer for certain elements. So what creates new layers? If we have 3D or perspective transforms in our app, if we have animated 2D transforms or opacity, then also we have another layer, but they have to be animated, so before and after they are animated, they are on the same layer. For the time of the animation, they're put for another layer. If we have an element that is on the top or a child of already existing layer, it can also be put to the new layer, to the new context. If we use accelerated CSS filters, in some special cases, video, canvas, or plugins like Silverlight or Flash. So the browser has this area where video is going to be happening or something is going to be moving. So the browser knows that, okay, it's probably a good idea to just pull this area out of the flow, put it on another layer so that it won't affect the rest of the page. That's why the the layer gets created. And last but not least, there is a will change CSS property, which is the only thing that lets us basically tell the browser explicitly that this part of the page needs to be taken out of the context and put into another layer, because probably something is going to be happening there. It's going to be important, so it makes for it to create another layer. To use will change, it's pretty straightforward. If we have our element, we just need to add will change and tell which property will be changed. So here we have a button that changes its transform property. So we say will change transform, and then it's on another layer. And in the time of the animation or interaction happening, it will actually have another layer. If it didn't have another layer up front, what would happen would be that, for example, we have this button. It's on the same layer as the rest of the page. We just hover over it. Browser quickly pulls it off to another layer. And after we stop interacting with it, so we are not hovering anymore, it will just, again, pull it to the same layer as the rest of the context. So what it might result in is like a small lag between the time the user hovers and the interaction actually happening. So that's why we have these layers. So there are two things to remember. First, we need to tell the browser upfront that the layer is going to be needed to avoid the small lag. And another is that every layer consumes memory, so we need to use them wisely. So we cannot have each thing on another layer, because each of these layers will get some of the CPU of the user's device. And the more layers, the higher is the chance that the browser will crash for our user. And this is not something that most users want, right? They don't want us to crash their browser. And last but not least, there is a compositing stage in our frame. So at this point, the browser just takes all the layers that we had and just glues them together. So we take the layers, and we have one image, one frame that is then shown to the user. And this is what is projected to the screen. So compositing always happens when we have more than one layer. And it has this superpower that browsers optimize for it. They might use a GPU for that. So like we use what's needed. Like we use graphic processing unit to show the image. So it's like a bit more optimized than the rest of the steps in the frame. For some interactions and animations. So why am I telling you this? Because this was an example frame, and the frames not always look the same. Some frames can skip some of the steps. And of course, if we skip some of the steps, then the browser has less work to do. As I said, this frame has around 16 milliseconds to happen, so that we would have a smooth interaction, smooth animation. It's really not much time, and usually it's not 16 milliseconds, it's rather like 10 milliseconds, because there is some cleanup after that as well. So types of trigger changes. There are 3 types of trigger changes that we can have during our interactions or animations. So first is a layout change, also called a reflow. This is a very heavy type of change. It will happen when we animate or transition things like width or margins or left or display. So anything that will have an impact on the geometry of the page, so on where the elements are going to be or how much space they're going to take. So if we change these things, basically, it's really a lot of work for the browser. It has to go through all the steps that we just described. So these are the properties we shouldn't be animating in any case. It's always going to be stuttering, even on our shiny new laptops, probably. Then there is a paint change, also called a repaint. So at this point, the browser knows exactly where elements are, how much space they're going to take. So it doesn't have to go through the layout step. It happens when we change properties such as background or background color, box shadow, background image, color, and things like that. So we don't change the geometry of the page. Browser knows where the things are, and it just skips the layout step. So it's a bit more efficient, but sometimes the paint step also can be very daunting when it comes to creation of the frame. So it's also better to avoid animating these properties if it's possible. And finally, there is a compositing change. So at this point, the browser skips layout and paint. And this is the most optimal type of change, and it happens only when we change properties such as transforms and opacity. And they all happen at the compositing stage. And at this point, as we said, the browser will take them to the GPU probably. So browser optimized for animating this thing. So if you're going to remember one thing from the stock, if you're going to animate anything or have some transitions, always use these properties on transforms and opacity. And transforms actually give us a lot of options, like you can scale, you can rotate, you can move things around with transitions. Using transforms, so it's like, so it should be enough for our needs usually. So how can we test if we have a problem? How can we test if we are actually experiencing any reflows or repaints in our app? Reflows, they can be quite obvious. Basically, if we have one element that is pushing another element away, or if element is changing its size or position and we're not using transforms for that, we're probably experiencing a reflow, and we might want to fix it as soon as possible because it will be just not nice experience for our user. But repaints, they're not that obvious. So in this example, the repaint is happening when the heart is overlapping the text. So it doesn't happen for the last star in each row because the text is not there. And it's not something you can actually know when you first see it. Like, you're not going to think about something like, okay, probably we're going to have some repaints here because the text is overlap. It's not something that comes to your mind. So for that, we need better tools than just our eyes. And these tools are the dev tools, which are the best for taking care of our interaction problems. Both Chrome and Firefox have fantastic dev tools when it comes to that. So let's go through them quickly. First is the perform. Oh, okay, it's not this way. First is the performance tab. Both Chrome and Firefox have one. So basically, this tab lets us record our interactions, and it will just show us like a very detailed report what happened millisecond after millisecond. This green bar that is very long, it shows us it has the number of seconds that the frame took, so you can click on it and you'll see what happened inside the frame. If you see that it's taking longer time, so here we have 33 milliseconds, so it's probably already we have some junk and we have some stuttering in this app, so we can click and see what took how long, and we can see where we can start our optimizations. To use that, we just need to hit this, this gray button at the top and start interacting with our page. So like here, we just hit the button and we quickly start to interact with our page, and then we stopped our recording. The shorter the recording, the better, because it's going to be more visible when we have problems. And as you can see here, as a result, we have these green bars. If they're tall, it means that we're having a pretty fast frame rate. We're probably around 60, but you can see that there are like this small holes. So this is when the frame rate was a bit lower. This is a fantastic tool. You can, it might be not visible in your DevTools. To get to it, there is this, so there is this 3 dots on the top right. If you click it, there is more tools, and more tools, you have all the tools that we're going to talk about now, actually. So, or you can use search in the DevTools using Command Shift and P. Then there is a Layers tab in Chrome that can be found in the same place. The Layers tab is fantastic for understanding how the layers work and understanding the stacking context of our page. So as you can see, we see the layers here. And on the left, there is a list of all layers that our page has. We can click on each of the layers, and then it will show us like what was the reason for creating this layer and how much CPU it took. So it will let us understand like what's happening actually. Unfortunately, this is a pretty heavy tool, and most of the time it just keeps crashing on me when I try to use it for more than a few seconds when I interact with the page. So you might have trouble getting to know like really well what's happening here. Fortunately, there's a fallback. There's also a rendering tab in Chrome, and it has something called layer borders. So if you enable that, it will show you just the frames around your layer. So it's a bit less advanced, but it's going to work better for most of us. Also, in this rendering tab, we have some other great tools. Like there is FPS meter, which just lets us have this small box that will tell us if we are hitting 60 frames per second. And for example, we can check if we have paint flashing. So what I was talking about earlier, we can spot if we are experiencing any repaints there. Also, it has some scrolling issues shown if you enable that. So if you enable the paint flashing and then FPS meter in your tab, it's what it's going to look like. So this green areas is basically what is getting repainted every time we scroll Facebook. So this is why it's so slow, basically, because so many things are happening and so many things are getting refreshed, and it's just scrolling there. And finally, there's one more thing about paint flashing, that it's not the same in, for example, Firefox as it is in Chrome. So when you scroll in Chrome, you are not bound to hit some areas that could be hovered. But if you scroll in Firefox, if something can be hovered, then probably you're going to hit it and it's going to repaint during the scrolling time. And it can actually make the scrolling a bit junky, so scrolling can feel not very performant. So you might want to check both Chrome and Firefox for that. In Firefox, you need to go to the settings, and there's toggle paint flashing to be enabled. And the last tool that is that can we use is Performance Monitor tab in Chrome. So you just go there, you start interacting with your page, and it's like a bit like EKG, I think. It just shows you how your website is performing at this given moment. So it shows like CPU usage at this very moment. It shows us reflows and style recalcs at this given moment. So you can just go to your page, start scrolling and hovering over things, and it will just show you how bad or good you're doing. So for the page that was doing pretty well, I saw that there was like a few % of CPU usage. There were no reflows, hardly any style recalcs. For the page that was really not performance, that was really slow, it was like 70 to 80% of CPU usage, a lot of reflows, a lot of recalcs, and my computer was just starting to take off when I was using it. So it can give you a quick glimpse on how well are you doing at this very moment. But probably if you're working on some like really big site that has a lot of elements on it, you don't want to go through all of these elements, like hover over everything, go to every sub page and check how well you're doing. So the advice that I can give you is that there are some UI patterns that are bound to be not very performant if you don't know what you're doing. They're bound to be causing some problems for users that are less fortunate and have a bit worse devices than we have for development. So we can probably spot them quickly and know where to look for the problems in our app. So what are these potentially dangerous UI patterns? Well, first of all, there are animations. If there is animation that is not optimized, animation that is, for example, using the margins and changing the display property, we're bound to see the junk and stuttering. It's just the browsers are not perfect in that matter. So what can we do about it? First, we can not overuse animations. So if your animation is not guiding user through the app, it's not giving feedback on what just happened, it's just not enhancing the experience, you probably want to skip that if it's only like for graphic purposes. You want to animate only transforms and opacity. As we said before, these are the two properties that will happen at the compositing stage when it comes to animating. The browser is optimizing for that so that we could animate these properties, and it's really going to be the smoothest thing that you can do. If you're going to animate with JavaScript, if you have something more complicated, if you need to schedule more animations with another and use, for example, some library or just in general JS animations, you want to make sure that you're making use of request animation frame function, which will basically make it easier for the browser to schedule the frame. And if the browser knows that it's going to miss some frame, it's not going to try to create this frame, the missed frame, not waste time on that. It just like it lets the browser schedule how the frames should be done, so it would be performant. But at the same time, if you want to support these 120 frames per second screens now on the consumer market, you want to avoid request animation frame. And it's because some of the browsers have implementation that is probably not going to change because of the backwards compatibility. And this implementation is like, request animation frame is not really doing what it should be doing. It's not requesting animation frame every time the browser, the device's screen refreshes. It just requests animation frame 60 times per second. So it has like this cap of 60 frames, and it will not go over to the 120, so we're never going to achieve this effect. So at this, in this case, you probably want to have CSS animations or web animation API, of course, with some fallbacks, and it will let us have really smooth experience for these screens if you need to support them now. Also, you don't want to animate elements that are below other elements because of the layer promotion. You don't want to promote some things to other layers just by chance. And you don't want to animate too many elements at the same time. Even if your animation is perfect, it's just using transforms and opacity, and it's running really slow. And it's running really fast. It's going to run really slow if you apply it to, for example, 100 diffs. So if you're thinking about, I don't know, making a snow falling animation on your page for Christmas time, you don't want to have 1,000 small diffs animated at the same time. You might want to find a better way to do that. Then there is a parallax effect. It's absolutely my favorite. So basically, it's almost always going to be bad looking. I don't know why it's still on the web. It's never going to be performant. Actually, I was looking for a performance parallax effect demo, and this one is not bad. Believe me, it's like running very smoothly on my computer, but it's Mac, right? And what you can see here, like, you can see that the whole screen is getting repainted every time we scroll. And this is something that is called a paint storm. So basically, the browser needs to, repaint the whole frame. So you can imagine it's not very, it's giving a lot of work to the browser. It's a lot of work that browser needs to do to just show these things changing all the time on the web when we scroll. So, as I said, it causes paint storms, and it's almost always bad. If you don't want paint storms, don't use scroll events for parallax effect. I mean, in general, it would be better not to use parallax effect. Don't use background position for parallax effect. If you really need to have parallax effect on your page and you didn't manage to talk to the designer and say that it's a bad idea, then you want to use 3D transforms and perspective technique. It is going to be a bit more performant, and here's a link to how we can do that. Then there are fixed elements. So almost every page now has a fixed header or a fixed intercom icon in the corner. And what is happening, as you can see here in the corner, is it's just getting repainted every time we scroll. Like this fixed element needs to, like browser needs to create a frame where there is the rest of the page and this fixed element all the time. So this element will get repainted all the time. And if there is only one, it's probably not a problem. But if our page is like more complex and we have more things like that, then it's a good idea to get rid of that repainting. And fortunately, it's easily fixed. So we can use a will change property on that or transform translate 3D. As I said before, also 3D transforms will create new layers, but it's kind of like a backward compatibility hack. So will change is so well supported now that you actually should use will change. So for our fixed element, we can just add will change transform. It will be put to another layer, and there will be no repaints in this area. As I mentioned before, you don't want to be having too many layers in your page. I think like up to 3, maybe up to 5 elements that are on different layers is a good number. After that, it's getting to, like this optimization is going to actually be a bottleneck. So you need to test it, you need to find the right balance here. Then there are scrolling events. In general, you know that scrolling is very, very heavy action. As I told you, it went to the background thread in the browsers. So attaching any listeners to that is going to be making it a bit slower. So you just don't want to attach will or touch listeners to the whole document. If you really need them, you would rather want to have some smaller areas with this attached. And you might want to take advantage of what's called passive event listeners. Of course, there is no IE support, but I think it's not going to be a problem soon. So why this passive event listeners? Like, what's going on? Basically, if we have our page and we attach scroll event listener and we have something happening with this event listener, the browser will anticipate that at any moment when we scroll the page, we might call prevent default from inside of this function. So it just gives a bit of like background work for our browser to think about it, like, oh, I think there might be prevent default at any moment. And if we pass this passive true flag to the browser, we're just telling we're never going to prevent default, we're never going to stop scrolling from inside of this function, so we can not think about it. So it's like a bit less work for the browser, a bit less work that the browser has to be doing. And actually, there was a Chrome intervention some time ago. So since version 73, all wheel and mouse wheel listeners are passive by default. So if you're actually wanting to call prevent default from inside of this listeners, you might check if your page is still working, because because they just made this passive true by default. And yeah, so that's why I want to use it. Then there are hover effects. Like every page has hover effects. Like we just hover over buttons, hover over links, and things like that. So the thing is, they're harmless until we have too many or until we have too big areas that get hit when we scroll, for example, in Firefox. So as you can see here, we're scrolling, and sometimes we just hit something that gets highlighted during that scrolling. This is what's causing then scrolling to be a bit slower, a bit junkier, unfortunately. So if you know that this hover effect is bound to happen often, you know that the user is going to definitely be hovering over some elements, you might consider adding will change property to that, putting it into another layer. But then again, you need to remember about this rule about having not too many layers. Yeah, they can be deadly if there are too many and they're too easily triggered. Even, I don't know, scrolling things on mobile when we have big images that are links and you by accident just go to some links. I think it's just not the greatest user experience. And also, you want to avoid triggering layout or paint. So again, you want to only change transparency and opacity. And here's a fantastic link to a page made by Paul Lewis from Google. And he basically took all CSS properties and wrote like if they're going to trigger Reflow or Repaint or only Compositing. So you can go there for the reference if you're not really, if you don't have this feeling, if you don't have this intuition what can be actually triggered by animated or a transitioned property that you're willing to change. Then we have appending of the elements. It's very heavy for the browser. As you can see here, we're adding just a pseudo element after elements, and it basically repaints the whole context of the page down on. So here it's not really a problem because we don't have that many elements. But if we have a really big page, very complicated page, and we somewhere at the top will just I don't know, on hover, show something like that, then it can result in a small lag. Something might not really feel performant at this moment. So what we might want to do is just to make sure not too many elements get affected. And for that, we might, again, want to try to separate the area with will change property or contain layout, but I think it's not yet there. It's not yet usable. There are some differences between how the browsers will interpret that, and basically it's once it's in the browser, it's going to be very useful. It will just tell, okay, this area shouldn't affect the rest of the page, and what's outside of this area shouldn't affect this area. So it's going to be like a bit like will change, but maybe more optimized for our needs, but it's not yet there. So once we have this separated area with will change, we might want to, for example, set like a height on this area so that it wouldn't change, it wouldn't cause any reflows, and put some overflow so that it would be just scrollable. And in this way, we're not going to be causing a lot of reflows for the rest of the page. And last but not least are images, which are not really interactions, but there are so many things when it comes to interactions around images that I decided to talk about it for a second. And also there are so many things with images that can go wrong that I've chosen only 4 things to talk about. About the downloads, about the content jumps, about how we optimize incorrectly sometimes, about the lazy loading. So when it comes to the downloads, it turned out that semantics means performance. So whether we use the correct way to embed the image on the page might it affects the time of the download. So if we and there is a fantastic write-up by Harry Roberts from CSS Wizardry on that topic. So basically, if we choose image tag, it's going to be downloaded at the same time as the CSS or even before the CSS sometimes, depending where you put your CSS in your markup. But if you have a background image, it will only start to get downloaded once it's discovered inside of the CSS file. So if your site is like image heavy or images are the core thing that users need to see very early and they're important, then probably they should be embedded using the image tag, not the background image. And in a similar manner, if images are secondary content, they're just an addition to your page. Probably you want to use background image for that because it will just affect the time of the download. It might cause that some things won't be offloaded in the time. The images will be just downloaded at the time they're only needed. Sorry. Oh, and one more thing. If you have images that should be only visible for the smaller versions of your page, like let's say hamburger menu icon or something like that, you want to reset the and you are using background image for that, you want to reset this, like you want to say background image none for this element, otherwise it will get downloaded for the bigger screens too. So you might want to avoid some unnecessary downloads here. Then content jumps. So everyone experienced that, like you go to the page, you know what you're looking for, so you just scroll down and you read the text, and then some image from the top just gets downloaded, offsets everything that was on the page, and you don't know where you finish reading. Fortunately, it's not happening in Chrome anymore because they enabled scroll anchoring by default since version 56. I think Firefox did the same very recently, like last week or something, but I need to confirm if it's really working. But if you want to support also other browsers, then probably you want to have some technique to fight with that. And the perfect thing is using a placeholder content and what's called intrinsic ratio technique. So and it works also for fluid images. So it's just working very well. So you just take your image, you divide the height of the image by the image width. You multiply it by 100%, and then it gives you some percentage, like say 60%. You get a container, you set padding bottom to this percentage, set image, height of this container to 0 and overflow to hidden, and inside it you put your image with the absolute positioning to the top left, and it's just, you have this area that is waiting for your image. You don't have content jumps this way, and you can style it freely. So it's like really, really helpful technique. Optimisations. So of course, less images, better performance. Images are going to be probably the hardest thing for your performance. Like they're like really. Now everywhere we have a big hero image that weighs way too much. So if you can skip some of the images, it's probably going to be better for the performance. You also want to use correct format. So rule of thumb is JPEGs for the pictures, and like PNG or SVG or other graphical thing, other formats like WebP for the graphical content. And you want to make sure that the optimization is the very last step of the pipeline. So if you go through the optimization like image optim or tiny PNG, and then decide to, for example, resize the image, you need to go through optimization again, because otherwise it just doesn't work. And then last, we have lazy loading, which is in general, it's perceived as a good technique, but sometimes it can actually be not very helpful. Sometimes it can cause more problems than it will help us. So there are situations like, for example, it can cause content reflows, and Zalando has a great case study where they basically said that they had lazy loading, but they decided to rather go with low quality placeholders. So like from the technique that we were talking about earlier, like they have some areas that are waiting for the images to get downloaded. Also, if you don't have that many images, sometimes a script for lazy loading can be actually heavier to download than the images itself. So just try to test and don't optimize too early. So these were all the UI patterns that I had that can go wrong. So So just let's look at the takeaways. So the junk happens basically when the device refresh rate and browser refresh rate don't match, and the browser doesn't finish rendering a frame on time. We should try to offload and optimize our main threads and avoid content reflows and repaints, so use only transparency and opacity for our animations. We shouldn't overuse layers at the same time, and always test with our dev tools, so performance, layers, and rendering tabs can be helpful. We should really be responsible when we use potentially dangerous UI patterns, the ones that we just discovered. Here's a list of resources. I'll just post a link to the slides later. And thank you.